Hi, everyone. Thanks for joining us for today's Safety and Health Magazine webcast, sponsored by eHazard. We are going to give our audience just a minute to settle in, and we'll start the presentation shortly. Thank you. Once again, folks, we'll start the presentation shortly. We'll let our audience settle in for just a moment here. Thank you. Well, a formal hello to everyone, and welcome to today's Safety and Health Magazine webcast, Utility and Industrial Awareness on Electrical Protection for Hands, sponsored by eHazard. My name is Barry Botino. I'm an associate editor at Safety and Health and a co host of our On the Safe Side podcast. I'll be the moderator for today's event. Before we get started, I'd like to share a few housekeeping items. First, the views of today's speaker and organization are their own and do not necessarily reflect those of the National Safety Council or Safety and Health Magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or the magazine endorses those items. We will conduct a Q&A session with our speaker after today's event. If you have a question at any time, just click the Q&A button located at the bottom of your screen, type in your question, and press the send button. After this presentation, you'll also be asked to complete a brief evaluation survey, but I'll tell you more about that a little bit later. Finally, this webcast will be archived. If you want to view this presentation or any of our past webcasts, you can visit us online at safetyandhealthmagazine.com/events. You may also receive a link in our post-event email. Now let's introduce our speaker. Joining us today is Zahir Juma. Zahir is a partner at eHazard and conducts electrical safety training and arc flash studies across the country. He has extensively researched and published on arc flash incident investigations and how to implement them in industry. Zahir also has contributed to the NFPA 70E standard. And with that, we welcome you, Zahir. Please take it away.
Thank you so much for the introduction, Barry. Hello, everybody, and it's so good to be with you all heading into summer. And I know everybody is expecting like bright blue skies everywhere, but I ended up traveling this week. I really wanted to do this webinar from home. So I'm not at home, I'm on the road, and I've managed to secure some good office space. So I'm excited. I'm pretty set up here. So let's cross fingers and hopefully everything goes well and smoothly from a technical point of view, like software and hardware point of view. So we're talking about electrical hand protection today. And the reason that I wanted to talk about hand protection is because if you all have attended my previous webinars where I'm talking with you, it's always been that I'm looking at it from me being out in the workplace, me being performing electrical tasks, opening up electrical panels, accessing difficult to reach areas, working in extreme conditions of heat, cold, rain, and all of these. And my aim in all of this, and this has been pivotal throughout my entire career, is how do we make safety easy to understand, and how do we make safety from a personal protective equipment point of view comfortable for people? Because at the end of the day, I'm a user of this equipment, so it matters to me what we have in the field. And that's the reason that I like being involved in the standards work and contributing towards them. Now, before we jump into electrical hand protection, I need two things from you, which is very, very, very important to me to be able to help you all. Firstly, you all know that I love electrical safety. I love the engineering part of it. I like the sciencey, nerdy part of it. But I absolutely love the human aspect of it because my wife tells me I never understand people. So I work very hard to try and understand people through the work that I do. So I'm a work in progress when it comes to that. But what I want to hear from you, and here's the two things, is number one, let me know what topics you would like to hear. I'm really curious. I can talk about 50 different things pertaining to electrical safety, and it doesn't add any value if it's not what you want to hear. Now, sometimes there's going to be big developments, and I'm going to be talking to you about those big developments, whether you want to hear it or not. And the second thing that I want to ask you is there's a Q&A session at the end of today's webinar. Ask me any electrical safety related question that you have. In fact, you can even ask me electrical engineering or application questions as well. I probably won't answer that live. We'll try and answer that offline. The other thing that I like to assure our listeners of is that even if I'm unable to answer your questions at the end of this webinar, I will make sure that me and a group that assists me of other subject matter experts, we will answer your questions. So your questions do not have to be limited to hand protection. Ask me any other questions. And remember, send me a note on the chat and let me know what topics interest you. What would you like to hear about? All right. And with that, let's jump into electrical hand protection. So I had to click on it 3 times before the slides moved. Gave me a little bit of a heart murmur there. All right, so what we're going to be discussing today is first, let's talk about electrical hazards, because electricity, people think electricity is electricity, it only harms you in one way. Well, we have 2 different electrical hazards. Let's talk about them. Then let's talk about our day-to-day work, because our day-to-day work exposes us to multiple hazards. And those multiple hazards require multiple solutions, unfortunately. In today's presentation, I want to try and explain to you, why don't we have one standard that covers everything? Why do we have so many standards with regards to hand protection? And how can you implement electrical protection even when you are performing non-electrical work? What are the limitations of these? So we'll talk about those. We'll talk about the local and international standards and what I'm seeing kind of developing in the field. So let's start off first. Do you know, one of the things that I firmly believe in is to understand the more advanced stuff, you have to be brilliant at the basics. So what is the basics of electrical safety? It starts off with the question on what is an electrical hazard? Any hazard is anything that can cause potential harm or loss, right? So when we look at electricity, electricity presents us with 2 hazards. The first, well, I cannot say the first, one hazard being electrical shock. And electrical shock, you can get shocked by touching something, and today's topic is all about touching stuff. And you could get injured by stepping across a potential. Think about cattle in a field in the presence of a lightning storm. So sometimes it's not through contact, but it's being in an area where where the ground has become energized. So if you look at the first electrical hazard, or one of the electrical hazards being electrical shock, electrical shock can harm you through touch potential and step potential. Then the other electrical hazard we have is electrical arc flash. An arc flash is basically when electrical failures occur, and they can occur through human contact, they can occur through electrical equipment failing, they can occur through even without anybody being there, even with the equipment being in good condition. There could be environmental factors such as dirt, dust, debris, environmental process contamination that could cause equipment to fail. When electrical equipment fails, the way imagine the way a garden hose would just rapidly fail, and you'd get like uncontrolled release of water just squirting out through that garden hose. Similarly, electricity is going to leak out, but that leak out is not a slow little leak, it's aggressive. It's an uncontrolled release of energy. And with electricity, what happens is, think about a lightning strike where that electrical pressure is high enough that it breaks down the air. And when you break down air, you get plasma formation. Plasma, think about a stroke of lightning. That's what an arc flash is. So when you get that arc flash occurring inside equipment, think about this. That equipment's not going to be able to handle that energy. So you're going to have that equipment building up pressure. You're going to have that equipment catastrophically failing. You're going to get molten metal splash. You're going to get infrared radiation. We're talking thousands of degrees Fahrenheit here, and I can convert that very easily. It's also thousands of degrees Celsius. Okay, for those of you, yeah. It's good to be exact on some of these things. All right, but under this temperature conditions, what's going to happen is equipment is also going to melt, it's going to break down, you're going to get projectile as well, not just molten metal splash, but you're also going to get like pieces of this equipment blowing out to the worker. So obviously the worker's got to protect themselves, but think about what's going to be closest, what's going to be the absolute closest to this failure mechanism. What? It's going to be our hands. It's our hands that's going to be the closest to this. So that gives rise to our topic, right? Now, let's talk about where and how these hazards exist. I think I discussed it a little bit in terms of arc flash, but electrical shock. Electrical shock, think of water flowing in, we use the analogy of a garden hose, right? But imagine that you are now an extension of that garden hose, where you're holding the end of that garden hose in your hand, and that water is now flowing over your hand and over your body. Similarly, when we make contact with electricity, the electrical current, the charge in the system, the charges, the electrons in our body then start flowing under that electrical pressure. That is what a person experiences during electrical shock. All right. So let's talk about electrical shock first. For electrical shock, for the hazard to be present, according to OSHA, we need more than 50 volts, 50 volts, either AC or DC. OSHA does not separate those two. They talk about 50 volts and they incorporate both AC or DC. Now, that is the hazard. When is the hazard present? The hazard is present whenever we are approaching or we are making contact with an energized electrical circuit part or conductor, right? So what does approach mean? For you and I, and for the purposes of today's presentation, we'll just stick to like the low voltage basics. I can also talk to you all about high voltage. The rules and the mechanism is slightly different at higher voltages. But if you look at voltages like 600 volts and below, generally it's within an arm's length. So if you think about an arm's length where unintentional contact is possible, that is when you enter the shock boundary. So once you enter that shock boundary, which is roughly an arm's length, it's 42 inches, 1 meter, 1,000 millimeters, 3 foot 6 inches, whichever unit works for you. When you get into that boundary, OSHA now says that there's a likelihood of you receiving an electrical shock. Now, we have another boundary. So the first boundary that I explained to you was the limited approach boundary. The limited approach boundary is kind of, think of it as the limit of your safety. So once you enter the limited approach boundary, you are now exposed to the shock hazard, means that there's a likelihood, very strong likelihood of you receiving a shock. What is a restricted approach boundary? The easy way to understand the restricted approach boundary is when you enter the restricted approach boundary, you are considered touching the equipment. You are considered as working on the equipment. What that means is if you pull out your cell phone and you go in to take a picture of that equipment, and let's say at 208 volts, you get to within 1 foot, for the purposes of OSHA and the NFPA 70E, which are the two kind of leading authorities and directives that we have with regards to electrical safety, according to those standards, you are working hot, you are working energized. It's as good as you making contact with the electrical circuit, right? So just to be clear, even if you stick your cell phone out with your hands holding the cell phone and you're 1 foot away from this energized circuit part, you are considered working hot. Right now, what are those distances? From above 51 volts, okay, 151 volts, greater than 150 volts, right? We'll be talking about multi-phase circuits like 208 volts, 240 volts, well, single phase 480 as well, which is 277 volts, 480 volts. And for our Canadian friends and other countries who are listening in, 600 volts, 575 volts, 525 volts, all voltage levels that people are working with. The restricted approach boundary is 1 foot. 1 foot, 30 centimeters, 0.3 meters, whatever unit works for you. But for 120 volts, these are your single phase receptacles, your power outlets, right? In the US, we have 120 volts. For those between 50 volts to 150 volts, the restricted approach boundary doesn't exist. It says avoid contact, avoid contact. Okay, I want you to take everything that I've said now about electric shock, put it in your back pocket, just keep it aside because we're going to get back to it just now. Now I want to talk about arc flash. For the arc flash hazard to be present, like we said, for the shock hazard to be present, all you need is greater than 50 volts, exposed energized conductors and circuit parts, and you being inside the shock boundary, the limited or the restricted approach boundary. That is when you are exposed to the hazard. When are you exposed to the arc flash hazard? You are exposed to the arc flash hazard when a shock hazard exists. So whenever you have a shock hazard, you have an arc flash hazard. But there's another part to the arc flash hazard as well, which says when you are interacting with equipment in a manner that can cause the equipment to fail. So think about this. I cannot have a shock boundary. I cannot have a shock hazard. Sorry, cannot have a shock hazard with the equipment completely closed up. Think about a disconnect switch. Think about a control panel with the door closed. Think about a motor control center. Think about the traditional electrical equipment you have. You can even think about the panel board you have in your garage or in your basement, right? When you moving those breakers, you turning things on and off, there are no electrical exposed circuit parts. And if they are, you're probably not code compliant, all right? So generally in stuff like that, you won't see exposed energized conductors or circuit parts. So that means that a shock hazard doesn't exist when things are closed up. But by you turning on and off that circuit breaker, you can cause an electrical arc flash, right? So, and the definition of an arc flash hazard is that an arc flash hazard exists whenever a shock hazard is present or when you are interacting with equipment in such a way that can cause an arc flash. All right. And you'll see at the bottom of my presentation, I have some references, and those references will point you, if you need to read more about those definitions, or just reach out to me and I can help you. All right. Now, remember earlier I just mentioned on the previous slide, I mentioned that there are standards that drive and direct our activities around electrical hazards. One of the international consensus standards is the NFPA 70E. NFPA, National Fire Protection Association, 70E. Okay, this standard dictates human behavior, work practices, some equipment design, some maintenance directives with regards to achieving electrical safety. Now, this is a national consensus standard, and the angle is, I know a lot of you are thinking, well, is it compulsory? Do I need to follow it? And here's what OSHA says. OSHA says that it will not give you a citation saying that you did not comply to Article 110.3, for example. They will not issue you a citation directly on that. What they will do is they will issue you a citation with the relevant OSHA requirement. And then what they would say is that the NFPA 70E, for example, would have given you the means and the methods to be able to achieve this requirement of OSHA. And that is what the average person would have used. So that is why the OSHA doesn't enforce NFPA 70E, but OSHA has the potential to reference it. In fact, OSHA has a letter of interpretation. A letter of interpretation is obviously OSHA, OSHA implementing, clarifying their own standards. Because sometimes the way OSHA is written, some of these requirements, I even find it difficult to read and interpret. So if you have a problem interpreting this, what you do is you write to OSHA. OSHA will then answer your question and interpret the standard for you. And once OSHA does that, interestingly, you can actually present that letter of interpretation in a lawsuit. Okay, and OSHA can actually say that we have interpreted the standard and they can reference the letter of interpretation in their standard as well. So letters of interpretations from my angle, are as solid as a standard, as an OSHA standard itself. So we take letter of interpretations very, very seriously. OSHA has given us an example on the letter of interpretation. It said to be safe, a person needs to understand what's the arc flash boundary. The arc flash boundary is basically that sphere. It's like a ball. If you're in the ball and if you don't have protection, you will get burned, and the burns will likely cause damage that could be permanent. Okay, if you're outside of the ball and you don't have any protection, you are going to be fine. You're going to be able to walk away from it, right? So think about that sphere. Inside that sphere is called the arc flash boundary. What OSHA says is that they do not define that in any of the OSHA electrical standards. The OSHA electrical standards, 1910 subpart S, 1910.269 for power generation, transmission, distribution, and similar. And you've got 1910.268 for telecommunication industry. You've got 1926, the construction regulations, etc., etc. Okay, OSHA does not reference the arc flash boundary in any of those standards, but they use the NFPA 70E as a means for somebody to know that an arc flash boundary is important. Okay, so understanding that the NFPA 70E is an important standard, understanding that OSHA is an important standard, let's jump into shock protection. We're going to talk about shock extensively, and then towards the tail end of the webinar, I'll get through to arc flash protection. All right. And today I don't have a very long webinar. That's why I'm spending a little bit more time discussing some of the basics that some folks may not be familiar with. If you understand all of this and it's well within your wheelhouse, thank you for being patient with me while we did this. You won't believe the number of people who reach out to me and ask me, Zahir, we don't understand what's arc flash. We don't understand the difference between arc flash and shock. Aren't they the same thing? No, they're not the same thing. All right, so let's start off with the electrical shock protection. You all probably read through the slide, and you can see that NFPA 70E, Article 130.7C7, which is based on the shock tables, says that we need rubber gloves when we're within the restricted approach boundary with leather over protectors. The reason we need the leather is because although the rubber is electrically strong, it's not mechanically strong. So we need the leather protectors to be able to offer that mechanical withstand to the rubber, to be able to protect the rubber, which is the primary source of electrical shock protection for our hands. Right? The gloves are limited to the circuit being worked on. And that's why I've got this picture out here. Because this arrangement is something very typical that you would see if you have industrial control panels. Sometimes people don't get into these control panels, but let me tell you as well, another easy way for engineers to design systems and for electricians to build systems is something called a wire trough. And a wire trough or a wire channel is typically where you could come in with very large cables and then you could split those cables out to feed other smaller loads. Why is that wording that gloves are limited to the circuit being worked on? Why is that an important statement? Well, if you look at this picture and you imagine that I am trying to test voltage, and let's just guess a voltage. Let's say that the system on the right-hand side, the smaller power block or power terminals, that those are 208 volts. Let's just be crazy and call that 208 volts. And then you can clearly see that on the right-hand side with the brown, orange, yellow wiring, that is generally the industry standard for 480 volts. So you can see you've got the 480 volt power block. What the standard is saying is that if you take a meter and you go to that smaller power block on the right-hand side, you are only protected with that glove for the circuit that you are working on. That means that the glove is not designed to protect you to the larger 480 volt power block that's out there. And this is a very important requirement because I've been present in several lawsuits, heard several arguments, expert witnesses, depositions, testimony in court and stuff. And these things come up in terms of, well, if the standard says that you were not protected against this 480 volts, then what did you do as a qualified employee? What did you do as an employer? What did you do as the person that was training the person that was injured? And those are the questions that they would ask. So, just as an aside, because we don't talk about this stuff often enough, if you are working on that small power block on the right hand side, that's 208 volts, and you're exposed to the 480 volt, just saying to the electrician, hey, dude, don't touch that stuff. It's not going to end well if you do touch it, is not adequate for safety. Why? Because when we are working, how many of you, when packing your dishes away, or maybe even adjusting doors of a cupboard or whatever, you're working in your kitchen, you're adjusting the door at the bottom, and you end up with a head injury? Why do you end up with a head injury if you're working with the doors and the cabinet and the drawers at the bottom? It's because you left the top cupboard door open, your focus was on the bottom, and when you stood up, you ended up bumping your head on the door that's open on the top, right? So you and I are not able to protect ourselves from hazards in our kitchen. Okay, and probably it's only me who's doing that. You all are probably more aware than I am. But if we can achieve safety in our own kitchens, how are we just saying to an electrician, dude, go out there, do the work, you're going to be cool, it's all okay? It doesn't work that way. So consider covering up the additional hazards. All right. So we're going to get into the standards and stuff just now. The stuff that I'm speaking about is practical stuff that people ask me for. So please be patient with me until we get to the standards. Okay. The next question I have for you is what about testing of outlets? 120 volts. Do you need a glove? Do you need hand protection? Now remember, the meter you are using is probably doubly insulated. That means it's got a double layer of protection, like insulation around it, number one. Number two, the probes that you are using are also insulated and tested far above the 120 volts that you would ever work on. All right. So my question to you is, do you need a rubber glove? And let's not guess the answer. Let's look at what does OSHA state, what does 70E state. But importantly, I'm curious to know, what is your work practice? Just ponder on that for a second, okay? What are you allowing? So let's see what OSHA states, right? And you all can read through all of this. What it says is, the probes are designed so that the employee's hand cannot slip up. So what that is if you ever hold a probe on a multimeter, you know it's got that little ring in the front, right? That ring is there to make sure that your hand doesn't slip through the probe, right? So those are our kind of finger stops, right? So that's the first requirement. The second requirement is where there are no exposed energized circuit parts that the employee's hand might contact during testing. So what that means is, if you've got a receptacle like a normal power socket, a power outlet, then obviously everything is closed up. As soon as you remove the covers and you take that out, you've got 120 volts, you've got exposed conductors. So OSHA is saying that here you need to use rubber insulating gloves. But let's now say everything is perfect, it's up against the wall, it's working correctly, and you're going to test on it. According to OSHA, it means that you've met the first requirement where your hand cannot slip up because you're using a meter that has the end. The second, there's no exposed circuit parts. I'm talking about a regular receptacle in your house, right? There's no wires, there's nothing that you can actually push your finger in inside one of those terminals and receive a shock, right? So you do meet those two OSHA requirements. Now, because you meet those two OSHA requirements, OSHA states that a rubber insulating glove may not be needed in those two conditions. But I want to be very clear here. OSHA is clearly limiting this to work on a receptacle or an outlet without any exposed parts, right? So are we cool? And the answer to that is no, because OSHA states that OSHA will follow NFPA 70E. So NFPA 70E, question number one, what is the restricted approach boundary when you are considered working live? What is the restricted approach boundary for 120 volts? Who remembers that? The answer to that was avoid contact. So number one, you are inside the restricted approach boundary when you are no longer avoiding contact because you are physically putting a meter onto this receptacle or this outlet to be able to measure. So you are no longer avoiding contact, you've now made contact. What is a definition within NFPA 70E of working on equipment? That definition within NFPA 70E, and I'm paraphrasing here, states that working on is coming into contact with any circuit parts, either intentionally or unintentionally, irrespective of the PPE or the tools that you are using, and irrespective of which part of your body comes into contact with it. So you are considered working on, even if you are using a tool, right? Even you're using a tool that's insulated and you make contact with something, you are considered working on. The requirements for working on an energized part is that you need to use personal protective equipment that is adequate for the hazard that you are exposed to and for the specific part of your body that is exposed to that hazard. And that is OSHA 1910.335. Okay, that's where that clause comes from. So clearly, testing is touching and avoiding contact is not possible. What NFPA 70E is stating is that yes, you do need hand protection. And this is such a hot topic. I've heard people get emotional discussing this topic. All right. But folks, think about it from a human standardization. Think about it from habit forming. All right. If I'm using a glove whenever I pick up a meter, if I'm using a glove whenever I pick up a tool, I'm getting into that habit where my body is getting used to be able to work with that glove on. If every single time I'm just looking to get that glove out as soon as possible, there is going to come the time where accidentally don't realize that I'm not using a glove and I make contact with a tool or with a piece of equipment unintentionally, of course, and receive a shock or cause an arc flash, or, these things can cause disabilities, fatalities. Okay, that's the reality of it. Most of these arc flash incidents start off with our hands. Our hands are involved in it. All right. So let's jump into the glove standards now. Gosh, how am I going to keep talking about standards interesting? I don't know. Let's see how this works. All right. Wish me luck, folks. All right. So, first and foremost, what was the history of this? Well, back in the day, they only used leather and it was predominantly cowhide. Think about people who were laying down sleepers on a rail yard. Think about people who were using these large hammers to try and knock down sleepers and rails and construction work, pounding out heavy nails into bridges, welding. So that's what you use these gloves for. But now, as we've evolved, we've said, hey, while the person is suspended in that area and they're probably using a glove for grip, the person also has some electrical work that they may need to do, or they may have welding that they need to do. So all of a sudden we realize that, hold on, there are other hazards that we have, and you can read through all of those, right? So conductivity can obviously become also an issue for those of you who work in area where static is a problem. You also need gloves that are going to prevent static discharge. So you need to be conductive. If you're working on overhead power lines, you're going to need conductive gloves so you get to that same potential, that same voltage as a power line that you are working on. All right, that's a little bit more detail. But interestingly enough, we also need gloves that protect gloves, right? So things have evolved. So let's start off with the basics, with the bare bone basics. Electrical shock is what we are trying to address now, right? In this slide, electrical shock. So for electrical shock, it's the rubber glove which is important. The standard that regulates the rubber glove is ASTM D120, with the 2022 version being the latest. Now, what this standard does is it basically specs that if you have rubber gloves that's used for electrical protection, here are all the tests that you need to do. Here's the chemical test, here's the mechanical test, here's the electrical test. Okay, and what the standard does is it covers all of the production and the testing and the issuance of the glove, all of those requirements. What the standard does not cover is the care and maintenance. We're going to get to that just now. But what happens with this glove is, and I've got a little table out there. Hopefully you all can zoom in and see that table. But what they do is they take this glove, they fill it with water of a certain conductivity, right? It's got to be the same conductivity so that it doesn't matter which lab you test at, you're getting the same results. So they fill this up with water, and then they take the entire glove and then they put it into a water bath. Now you have an electrode that sits on the inside of the glove, and the entire glove is then in a bath, right? And so what we're looking for is the current that goes through the water on the inside, through the rubber, outside to the water in the bath, and we're measuring how many milliamps goes through. So if you've got like a smaller glove, like let's say a class 00 glove, we're looking for 500 milliamps, 500 milliamps, 0.005 amps, right? 500 milliamps. And we're going to hold that for at least 3 minutes, looking for that leakage current and making sure that it doesn't break down. Once it holds that, you're good to go. You've proof test your gloves. Your gloves are electrically tested, but they also call for destructive testing. So now every glove will have to go through the withstand before they issue you those gloves, either from the manufacturer or from the retesting house. We'll talk about the retest requirements just now. But what they do is during manufacturing, they will take out some of these gloves and they leave these gloves soaked for an extended period of time. And then they will take this and they will test these gloves. And these gloves need to meet a certain requirement. Then what they'll do is they'll take these gloves that have been already conditioned and then they'll ramp the voltage up. They'll basically go on and on and on and on and on with the voltage until the glove breaks down. And they have a minimum threshold for which the glove breakdown voltage. So for example, if you're looking at your glove, let's try that again. If you're looking at glove class 00, your minimum breakdown voltage, for example, is 13,000 volts before those gloves will break down. Now, I am telling you this for the purposes of educating you around the test. I am not saying under any one of these conditions that if we're testing a class 00 glove that's rated for use 500 volts maximum, right? That's rated for the 500 volts maximum, that you can now say, oh, well, it's tested to 5,000, so I have some leeway. It only breaks down at like 13,000 volts, so I've got some leeway in here. That's not the intention. We should never do that, because remember, these are destructive tests. Destructive test is a point of no return. You'll never get that glove to behave in the same way that it was designed to after you condition it for destructive testing, right? So besides the AC breakdown, they do a halogenation treatment, and they also do some other treatments because with some of these, like especially the latex gloves and stuff, they have like allergens in them. Some of these treatments help relieve the reaction of latex to people. I have spoken to a lot of people who have like a whole host of allergies and stuff. And what they have said is that whenever they use their rubber gloves, they do not have any problems with this. And I think that over the years, a lot of effort has gone into these standards to make sure that they work for you. Now, OSHA states that if you have a glove, you've got to take care and you've got to maintain this glove. So instead of muddling everything together and throwing everything into ASTM D120, ASTM F1236 was formulated, and it's actually referenced in OSHA, right? And that standard speaks about the visual inspection and in-service care of your gloves. And the other standard is ASTM F496. Now, let's talk about some of these mandatory requirements. These are for the care and use, okay? So field care. Every day before first use, you've got to do an air inflation test. So that means you've got to inflate your glove. You've got to make sure that it holds air. A lot of people have asked me, say here, when you're folding the glove up and you're having the glove hold air and you're listening for leaks, you are feeling for any air leaks on it, what about the area that you folded? Aren't you not testing that area? I would agree with you. That's true. But from our incident investigations, most of the glove failures occurs on the hands, hardly ever on the arms. Okay, so this is the area that gets the most wear, the most tear. That is the area that we're testing. Okay, so don't worry too much about just a fold or two just to trap air. It's okay. If that does worry you, you can actually get an air inflator, and that's like a little squeezy ball, and that basically pumps up the glove. You can use that. For me, that doesn't work because I'm a consultant. I'm traveling in all different plants all the time. I'm not carrying that inflator with me. I'm just doing my air test. And sometimes I would do my air test several times in a day. It's just we work in dirty environments. It's not they're not clean conditions like this office that I'm sitting in and stuff. So there's always a likelihood of this glove being damaged. When you look at silly things causing fatalities, you start focusing on being brilliant at basics, right? The other thing is you've got to perform a thorough visual inspection. You've got to store it in its natural shape. This is very important. And for those of you who are wondering now, can I leave the rubber inside the leather when I store it? I'm getting to that. You need to wait for that answer. All right. And then it's got to be electrically tested once every 6 months using the ASTM D120 proof test. Now, some of you can complicate this matter. Some of you keep it easy. Look, here's what the go-to on the standard is without getting too lost in the words. As soon as you take that glove and you use it, you put it into service, okay? You basically use the glove. Now, putting it into service, some people tell me, Zahir, as soon as I open up the plastic, the timer starts. Man, if you want to start the timer when you open up the plastic, good for you. Go and do it. If you want to start the timer the first time that a person put the glove on, good for you. That works as well. All right. It's it's entirely up to you on what you can justify and what you can manage. Don't get so lost in the detail that your program goes off kilter and you cannot get your gloves tested. Now, when a glove is tested and the glove it arrives on your site, you can actually store that glove in good environmentally controlled conditions for a maximum of 12 months without needing to retest that glove. So some people get very worried when they look at my glove date and the date on my glove says December 2024. I had this discussion recently. It said December 2024. And somebody said, well, December 2024, Zahir, you're getting pretty close to your test date. And I say to them, no, I only opened up these gloves in March. So I basically keep a record of here's when I started in March. Now, I am a little bit off kilter as well because there were some fun things that I did earlier this year, and I was kind of off with my timing and stuff. But what we do in our company is I personally have two colors of gloves. I've got a red glove and I've got a black glove. The first half of the year, I use my red glove. So from January until the end of June, I use my red glove. Then I'll give that red glove out for testing. And the second half of the year, I'll use my black glove. So if you have like a two glove program and a three glove program, because you should always keep like a spare or two around of different sizes, what you do is issue your glove towards the end of December, very early in January, and let everybody bring their old gloves in, send those gloves in for testing. When those gloves come back, whenever they come back, they can come back in March, April, whenever. Then you issue those gloves on July or 1 or the end of June, and then you let people use that glove until the end of December. So it doesn't have to be too difficult. Go online, use one of your search engines, look at laboratories that test gloves. Almost all of them would receive shipping. So you can use somebody that you can drive to. And if you cannot, put all of your gloves in a big box and post it out to them. Okay, it's not that expensive. I'm not going to tell you how much it costs, but depending on who you use for testing of your gloves, it can even be less than $10 a glove, substantially less than $10 a glove. All right. Or depending on who you use, it may be more than $10 per glove. All right. So the other requirement within 496 is that you need to have a dedicated person that actually looks at the success of this program. And I know that a lot of us are not compliant. What this means is that within your organization, you have to have a designated person that would actually go around and make sure that the glove program is being implemented as needed and has to document that program. And let that sit in because I believe a lot of us do not have that. within my company, we have somebody that's responsible for this. Make sure that we are using our gloves correctly, make sure that our gloves are stored correctly, make sure that our gloves are taken out and sent through for testing. And she does an absolutely stellar job of it. All right. And even if we're traveling, she will reach out to us and she will say, hey, where about are you? I need your glove. And we'll have that discussion. All right. And then use glove liners and glove dust. Avoid the talcum powder. The reason for this is they believe that there are some like moisturizing agents in there which act negatively on the glove, and they also act negatively on the leather. So with that, let's talk about protector gloves now. Now, when it comes to protector gloves, OSHA themselves are the one who mandate that the rubber gloves have to be protected using a leather over protector. Now, your leather over protector, you can get them in goat skin or cowhide. Those are the two most common types of leathers that we have. Now, in 2021, with work that a few of us had done, we had gone back to the 70E standard, and 70E used to say leather over protectors. The change that was driven was the word leather was removed, and we speak about overprotectors or overprotector gloves. So that change came about in NFPA 70E 2021, right? And then uh, in like after the 2021 standard was published, it was in 2021. Surprisingly, that we pushed through that letter to change that through a public input process. And in 2024, it was changed and the word leather was removed. So that's when overprotectors came into play. Okay, or that word. ASTM 696 standard specifies a snug fit for leather protectors, but that standard does not allow you to crease your rubber insulating glove. And this is a very important point because when we're talking about protected gloves have to be designed in a way that they do not cause wrinkles to the rubber. Now, this is important, and we'll get back in a second as to why this is important, okay? But protected gloves cannot be used as work gloves. In fact, here's what the standard states. If you use your protected glove just once to go and perform some mechanical task, or you got to cut something and you use it as a work glove, you cannot reuse that glove as a protected glove. You have to either discard it or use it continuously as a work glove. Okay, these gloves are in a completely different manufacturing league, right? The way that they are manufactured, they're not your bulk produced pigskin gloves. These are, there is a lot of engineering that goes in behind this. So you got to be careful of it. And not only does it offer electrical protection, mechanical protection for the glove, but it also offers thermal protection, right? Now, the rubber gloves have to be stored obviously in a careful manner. You cannot damage the rubber. Now, a lot of people say, hey, Z, it's just easy to pull out the rubber and the leather all at once and just put it into the storage bag. And I've always said to them that I personally separate my gloves. And the reason I do this is because if there's any moisture like from rain, environmental, or whatever on the leather, what some studies have shown is that, and in practice as well, it's been noted that from the tanning process, there are some leachates that come out of the leather, interact with the rubber, and cause weakening of the rubber insulating glove. And that's where we have rubber gloves that actually fail around the cuff area and not on the finger area. When we see things like that, immediately we know that it was contamination from the leather protectors. So here's what I do, folks. It takes me a few seconds to do, but I always pull out my rubber gloves from the leather over protectors, and I keep my leather protectors separately, and I keep my rubber insulating gloves separately. Now, if you want to store them, and if they're nice and dry, you know you don't have any problems, the standard does allow you to maintain this. But as you can see, we have so many challenges. We still have, what if I have shock protection, but I also have heat that I need to think about? What if I have something else? So a lot of these limitations on like, hey, the leather is reacting with the rubber, can't I use something else instead of leather that doesn't go through the tannery process? Well, to answer all of those questions, ASTM F3258 came along. But just wait a second. Before we jump into 3258, something very important. There's something very important I got to mention on rubber insulating gloves, and we've got like 10 more minutes to go, so I'm gonna rush. Not, I'm gonna run through these very briefly, not get into super detail. But what's important is it's not the color of the glove; it's the color of the label. It's the color of the label that dictates the rating of the glove. For low voltage, for most of us, we'll either have a beige label with a 00 on it, or we'll have a red label with a class 0 written on it. All right. And remember, folks, it's not about the peak voltage because at 480 volts AC, your peak is way higher than 500 volts. It's not the peak, okay? It's the nominal. It's what people call that system of voltage. So at 480 volts, you are perfectly fine using a class 00 glove. Personally, I use a class 0 glove because I like that slightly thicker rubber. It just gives me a little bit more mechanical strength. So while I'm in the field traveling in the middle of nowhere, I'm not going to have a glove failure because I was too rough on the glove. All right, so rubber insulating gloves, commonly used by power utility and commercial electricians, hardly ever used by residential folks, and they provide insulation for working on live line voltages. Now, on the higher levels, when you are using live line tools up to 36,000 volts, you can also use the heavier duty rubber insulating gloves. Typically, we don't use rubber insulating gloves above 36,000 volts. And there are some instances in which you can use it. It's a very specialized topic. Reach out to me if we need to discuss this a little more. All right. So the high voltage arena, we've got the National Electrical Safety Code, the NESC, right? Not NEC, NESC, and we've got 1910.269. Both of these high voltage standards allow barehanded work under certain conditions. We'll talk about them, but they also cover additional protection needs, and that's cut resistance and arc flash protection. So let's talk about leather protectors. Some of the limitations we've got is that for those of you who have clean room conditions, you know that leather is not going to work. And OSHA also says, OSHA doesn't say this, is that they do not consider clean rooms, they do not consider food, chemical areas, and other areas where as reasons to remove leather. They only consider finger dexterity. So here's where I've got a problem with it because energized electrical work can be difficult in these areas where we can make things simple, take all of our electrical equipment and put it outside of the clean room. Typically, we call those an electrical chase, or we call them the chase rooms. Those are not clean room conditions, so we can go and do electrical work there. But as soon as we have clean room conditions, now our leather gloves are not permitted. So what do you do in that case? Now, that gives rise to ASTM 3258. What 3258 does, it's a standard spec for rubber insulating gloves, for protectors for rubber gloves that meets performance requirements, right? For all the functionality that you would need from an overprotected glove. Now, this was a brand new standard. I think the first version was August, probably 2018, 2019, 2020, around about there. Just slipped my mind now. But what this allows is classification of other protected gloves, not just leather, right? So we use the 105 criteria, ANSI, for cut testing. And then the cut is basically you take a blade and you go over it, and then the depth of the cut would allow a certain classification. Puncture resistance, they use a pin and they puncture through the glove. Abrasion resistance, where they've got vibration and they've add some friction to it, and they look at the wear of it. Okay, so that's the glove that we would use. But here's a problem that we have. Remember that the protector glove, according to the protector glove standard, does not allow you to cause wrinkles on the rubber glove. So there's where the problem comes in. Think about your cut resistant glove, right? And think about the way it has that snug fit onto your hand. The problem is if your glove, if the rubber is very dexterous and can be actually folded and twisted and cause wrinkles, that cut resistant glove is not going to be a good overprotector. So that is where we are, and that's where the limitation of this is. So leather shows very like relatively poor cut resistance. So that's why now what they did was you have some gloves, like some synthetic material, that shows very good cut resistance, but they may not have enough grip resistance. So what they're now doing is they're creating composite gloves where you can have grip and oil resistance on one side, and on the other side you can actually have cut resistance. The only problem with it is, and well, another benefit is obviously the chemical resistance of it, right? The only problem that we have with this now is that it's going to start wrinkling those lower rated gloves. So that's why most of these solutions now are for class 1 and above, right? So these are all the issues that we just discussed. So um, class 1 at the moment is the only glove class that we have these composite non-leather overprotectors for. So we need more innovative solutions, and there are some stuff in the market. There are some people who are doing some absolutely awesome stuff, right? So with that, we're done with electrical shock. Let's jump on electrical arc flash very quickly. So what happens if you are working on an energized electrical circuit part where you have electrical shock but no arc exposure? Well, that's easy. We're going to just use our rubber insulating glove with leather over protection. But then you could have electrical arc flash with electrical arc flash. And did I just repeat that? Electrical arc flash and no electrical shock. So you could have the instance with electrical shock and no arc flash. Then you could have electrical arc flash, but no electrical shock. In that case, the second bullet point, you do not need rubber. You can just use any thermal glove or any arc rated glove or any heavy duty leather glove, and you're going to be okay. And then if you look at the third instance, well, now we're creating a problem because that third bullet point says electrical shock hazard and electrical arc flash hazard. So the traditional method has always been rubber insulating glove with leather over protector. Now, depending on the class of glove you have, you can also go with non-leather over protectors with cut resistance. Okay, so there are solutions now, and I think we've managed to address most of those. But when it comes to the arc flash, what they found was in retesting some of these gloves, and I put a picture of an example of what that glove would look like. It's not this particular product, it's just an example that I have out here. But what they found was that under certain higher energy exposure, they saw the initiating of melting. So because of that, they've changed now the 696 standard, which is the care maintenance use standard for these gloves, where they say now a minimum 20 calories per square centimeter is required. So now you've got to do a little bit of arc testing. But what I'm going to say is for your higher energy gloves, the ones which have those plastic, those polymetric type of materials and at the back, that rubbery, plasticky type of material, go and have a look at them and speak to your manufacturer and see whether it's still valid and whether you need to update those gloves. So look at your stock. And then ASTM F2675 is also a method for hand protective equipment to determine their arc rating. So it's not just leather or overprotector arc testing that can now be performed. Now you can take your rubber glove, you can even take your rubber glove with the leather overprotector and test it. The standard that you would use for that is ASTM F2675, right? And that now can also issue arc rating. So now you can actually stick an arc rating on your glove because we've got the 2675. Now we do have some international standards as well, and there's different marking requirements and all of that for these standards. But last few slides here, gloves for arc flash protection. Like I said, remember, you can have arc flash without shock, like switching something. So you do get gloves which allow you for cut that have cut resistance, and it will also offer you arc flash protection. And we said gloves up to 36 kV when a shock hazard is present. So what we have found is that in most cases, if you use your rubber insulating gloves with your leather over protector, you're going to be okay. Just make sure that your protector gloves meet both 696 and 3258. All right. And future development, like I said, there are rapid developments in these areas, but there is more work that needs to be done. All right, folks, so here's all the standards that we had discussed. And with that, we will conclude our presentation. And Barry, I'll hand over to you now for questions.
Thank you so much, Zahir. We appreciate you sharing your knowledge with us. Before we start the Q&A, I want to let everyone know about the evaluation survey we're asking you to complete. That survey will open in a different screen after this webinar. We're going to try to sneak a couple questions in here, Zahir. First
Mhm.
of all, Camilo would like to know how much incident energy can the combination of a rubber glove and a leather protector withstand?
So from the testing that we have done, it's very manufacturer dependent. Also, the class of glove matters, but we saw leather protectors being able to withstand about 40 calories plus 55 calories per square centimeter with limited testing. We've also seen rubber insulating gloves, class 00, class 0, do about 30 calories, 30 calories per square centimeter when tested individually. When tested in combination, we've had values of 40, 50, 60 calories per square centimeter.
Excellent. Our next question is from Michael, who says, Zahir, do you keep your gloves in a cloakroom or is there a specially designed locker or shelf for their storage? You said, maybe I might like to implement this in my company.
Yeah, for me, it's in my go bag. So I've got a roller bag which is always ready for me to travel. And that is 9 out of 10 times that's kept in my office. It's kept in my study, but it's in a controlled room. In terms of glove storage, it's going to be very difficult because your gloves have to be easily accessible. So you got to think about that. I would rather sacrifice on environmental conditions, but make sure that the glove is at my electrician's, like kind of just at the desk when they're ready to go. They should be able to grab and go. That would be
E-
my focus.
Excellent. And we see your contact information here on the screens here. So folks, if you'd like to contact Zamir, there's his email address. We're going to end with one more question, Zahir.
Uh-huh.
And it's an interesting one. Cheryl says, Zahir, have you written a book with all this helpful info?
No, no, but I do write several articles, so please keep up to date with the Safety and Health magazine. Attend the expo and conference. NSC puts up a great, great, great show at the end of the year. I think it's in Denver this year, Barry,
That's correct. In September, yes.
in September. Please make sure you attend that. I pick up so much education at those shows, and I'll be there this year. I'm doing a presentation on DC safety around DC, and I've got one of the national labs, Dr. David Rosewater, is joining me, and we're doing a presentation there. So if you can make it to Denver, please come by and say hello. I'd love to meet all of you in person.
Excellent. So here we look forward to you being there and we look forward to seeing you there. Folks, unfortunately, we have run out of time today. We thank you all for attending and we'd appreciate you taking just a minute or two to share your feedback via our survey. A big thank you goes out to our awesome presenter, Zahir Juma, and of course, everyone from our sponsor, eHazard. This ends today's Safety and Health Magazine webcast. Take care, everyone, and have a safe day.